Hello everyone, my name is Mircha. Apologies for not being present at this right moment. I am on a plane. I will be for the second half of the lecture. But I decided to make these videos, and in between the videos, Greg will be able to answer any questions you guys may have. So my name is Mircha Stanko. I have 20 something years experience in the stormwater field, and I have some education in civil engineering, in computers, and in public policy. The reason why I am talking to you today is because I like to share with you some of the background of why we do stormwater engineering, quantity and quality, how we do it, and how it integrates with the larger concept of life in general. That being said, let's start with a short talk about the history of water management by humans. So originally, the humans, and we're not going necessarily to the Roman Empire, they were very good, but typically and originally in villages or small townships, what you would have would be wells where people would go and just collect water from the well. They will dig a hole in the ground and they will reach an aquifer, and they will just use a bucket on a wheel to just, or two buckets with a rope, and they would collect water this way and bring water to the surface this way. They used to put a variety of chemical compounds, chalk, to clean the water to ensure the water is safe to drink. At the same time, what they used to have a latrine, which was another hole in the ground, somewhere away from this hole in the ground, that was used as a toilet, what you would know typically as an outhouse. So this is how water supply and sewer were handled for a large part of human history. Of course, we now know that this has the potential to lead to significant health complications, especially in places where there's a significant amount of humans, which is why sewer was invented. The way sewer was invented, I believe the first time sewer was invented was in Chicago. There's a story about the raising of Chicago. So basically what they did, as they were having health issues due to the latrine, the water underground was communicating as the water underground was moving from the latrine to the water supply and so on. So what they did, they raised the city of Chicago and they created pipes. Literally put all the buildings up on jacks and pipes discharged into the lake. And for a few months, this was very, very, very good. But after that, I think they're taking some water supply from the lakes as well. After that, they start getting sick again, and that was because the water, the sewer that was discharging in the lake was now poisoning some of the water supply that was coming back to the people. So this is what happened. In order to solve their sewer problem, the city of Chicago created a sewer which discharged into the Chicago River, which went into the Great Lakes, and then that contaminated their water supply. So after that, they had a big project, which was creating a sanitary and ship canal to reverse the flow of the river. So sewer doesn't go into the water supply. Now, this is just a general idea of the challenges that humans have experienced with water, and this only happened in the 1860s, 70s. It did not really happen before then. The stormwater, sorry, the water supply also, for as an interesting aside, water supply also has been treated with chlorine, not in the very historical past. The treating of water supply with chlorine recently is a recent invention. So in 1897, in England, the first time an entire town water supply was treated with chlorine, bleaching powder, was during a typhoid epidemic as an emergency measure, and the first continuous treatment of a town supply was done in 1908 by John Leal in New Jersey. Fun fact, John Leal went to court because he put poison in the water supply, because that's what chlorine is. But in the end, he won because he proved that the poison was actually cleaning the water. Now, I'm talking to you about these things to see that the history of water is quite interesting. Moving to, and we take for granted that we have clean water on tap, but that's actually not always been the situation. And water supply, sewer, and stormwater are interconnected in significant ways. Historically, when in Europe, when sewer was created, it was a combined sewer. It handled both stormwater and foul, what you call foul sewer. So toilets and stormwater go through the same pipes. But when Australia was developed, the decision was made to actually separate them, because it was recognized that sewer is not very clean, and it was considered that stormwater is a clean resource. So stormwater was considered to be clean. Now we know that's not totally the case, but definitely stormwater is not as problematic as sewer. So now, why do we have stormwater pipes? Well, it's pretty clear, so our cities don't get flooded. But the more importantly, or the concept is this: if you have a development, so if you have a piece of land, let's say somewhere upstream of somebody's house, and your piece of land is completely undeveloped, it's just a pasture, the soil absorbs a lot of the water and a lot of the rain. So soil acts really like a sponge. When water falls from the ground, it just goes inside the soil. The soil absorbs the water, and only when the rain is a little bit higher, then you have what's called an overland flow. So basically, the soil gets saturated and water starts flowing over the grass, over the land, into the river or the creek. A lot of the times the creek is fed by base flows, which is water falls over the soil absorbs the water, and then it releases some of the water slowly over time. So obviously, if the area is a pasture, is not impervious, the discharge from that area will have a certain profile and a certain peak flow. The moment the peak flow is important because the creek is basically handling a certain peak flow. The moment you put an impervious area, you just concrete over that surface, all of the water that will have gone down into the soil, it doesn't go into the soil anymore. The soil is dry because underneath the concrete, there's nothing, right? So in that case, the water falls on the concrete and then just discharges immediately into the legal point of discharge, creek. That creates issues because that especially will generate higher peak flows. Now, why higher peak flow is important? Because the moment you generate a higher peak flow, the capacity of the creek is not that great. Well, it's not designed. The creek has not been created or built or built by nature, right, to handle that kind of flow, which means it will start flooding downstream. So after a significant amount of issues for many years, when people upstream would flood the people downstream, we as a society got together and said, well, that's not really acceptable. And if you have a house that's downstream of somebody's land, you should be protected if that person decides to build some things. And your house should not start getting flooded just because somebody else decided to put a house or a barn or an industrial area upstream from you. So the need for managing stormwater quantity came due to this issue of people being flooded and their properties being devalued by changes in development upstream. So this is why this is part of land development. That is with the quantity, and quantity is calculated in one way. Quality is calculated in a different way, which is kind of crazy. But there are two completely different ways of calculating stormwater. If you do quantity or quality, we just talked about quantity a little bit. Quality, remember how I said that people thought, yeah, stormwater is clean, and then it just goes into a pipe system underground or into a swale on the side of the road, and then we just dump it into a creek and it should be fine. Well, turns out that the stormwater is not really that clean, and it will carry a lot of pollutants, different types of pollutants. We typically handle 4 types. Gross pollutants, which is everything about 5 millimeters. Leaves, sticks, wrappings, ciggy butts, things like that. And these gross pollutants are the ones that are easiest to get out of the water, but obviously visually they're eyesore, problematic. Another pollutant is total suspended solids. When water falls down, it can carry some sand and other small rocks, material that's under 5 millimeters. And you will see that if you drive around or walk around, sometimes next to the gutter. Really, it's a next to the gutter stormwater drainage pit. You look at the curb, and then there will be some hole in there. You will see sometimes sand gathered in that area, especially in a construction zone. You shouldn't, but you will. And that is because when it rains, the water carries all that sand and moves it all the way to the discharge point. Then there's other 2 types of pollutants: total suspended solids and total phosphorus and total nitrogen. And these pollutants are feeding algal blooms and other things. So they're nutrients, and if you have too much nutrients, you end up with low biochemical oxygen demand, and low biochemical oxygen demand leads to algal blooms. And you may notice that occasionally you're not allowed to swim in a lake due to cyanobacteria. Well, cyanobacteria develops because the water that comes into the lake has too many nutrients. Because of the too many nutrients, algae grows and consumes all the oxygen in the water. And as it consumes all the oxygen in the water goes anaerobic, and that lets anaerobic bacteria live. And some of the anaerobic bacteria is poisonous to human life. So that's when you have blue-green algae blooms. And that is for this section. Please ask Greg anything, and we'll move to the next section.